All right, good. Hopefully this will help everybody this evening. So this is me. Okay. I feel like I need to be completely straightforward, right? If you look at my picture now, I look a little bit older. There's a few years ago. But that's me. I'm Erik Gross. I've been programming computers for a very long time, but I've been a formal senior level software developer for quite a number of years. I'm a veteran. Spent 6 years in the Navy operating nuclear reactors. Kendrick, welcome from West Africa. That's fantastic. So I operated nuclear reactors and got trained. One of the things I was pretty thankful for is that because I was trained both as a nuclear reactor operator and as an electronics technician, the Navy spent a lot of time making sure that we all understood down to like the bare metal, like fundamentally how a computer works. And so there's never really been any mystery to these machines for me because of that quality education. And I've worked really hard to be able to explain the fundamentals to people brand new to technology so they have a really firm foundation when you start laying more and more layers of complexity on top of the fundamentals, which happens pretty rapidly in technology. I am the co-founder of the Tech Academy, a software development bootcamp headquartered in Portland, Oregon. So that's me, and I'm glad to be here. Some basic class rules. One, we do have an assistant in the chat. Regina is there to monitor the chat, answer questions. She just said hi to everyone. Please be very nice. If you're not nice, she'll boot you. Haven't had it happen in a very long time because generally people that are interested in tech are pretty cool people. I want to make one point, which is the class will be challenging. Now, we do break things down really easily for people to assimilate, to understand, to apply. But you're also learning a whole new way of thinking and a whole new way of controlling the computer because you're going to be in charge of creating the program instead of using a program, right? So just work through it. There'll be some challenges. It's part of the learning process. A big thing you can pay attention to make sure that goes well is to write the code exactly the way I write it. We'll be writing some code tonight. And it's really interesting. Even things like a misspelled word, a missing symbol, or even capitalizing something that shouldn't be capitalized can cause your program to have errors. One other point, if you're attending on a mobile device, which doesn't happen that often, but occasionally it does, it'll be real hard to do the coding, like on an iPhone or an Android or whatever. But please do attend and listen. It's ideal to do it on a full computer, but if you don't have access, you can still watch and listen, and you'll still learn a lot of stuff. Another thing you can do to make sure that you learn well is make sure you are in a distraction-free environment so you can focus on the class and so I don't lose you. Another key thing, I'll get to that to your question in a second, Carolina. Another key thing is this. If you fall behind in writing the code, don't lose heart. It's fine. Just stick around. You'll still learn a lot even by watching me go through it. I mentioned earlier about the links. This video, the recording, will go up on YouTube either later today or tomorrow, which is great. And we're going to create a game today, and we'll build little teeny bits and parts of the game. We'll also go through the full code for the game, and you'll get a copy of that full code so you can play through it and learn and tweak it and have fun. All right. We already all know how the chat works. I'll grab one thing. Carolina, go ahead and drop your question into chat, and I'll grab it as I can. Oh, yeah. Oh, no, this is a perfectly good question. She says, what computer would you recommend for working in tech, like for storage space and elsewhere? I'll give you 3 key things you want to look at right now if you're learning to be a developer. You don't need to buy the biggest, beefiest computer in the world to learn to be a developer. Outside of certain specific tasks or type of computer programs you're going to make, the general work of doing the development doesn't require a super powerful computer. If you've got a modern processor, from Intel, like an i7 or an i9, or a decent AMD processor, you'll be fine. That's if you're in the Windows world. Any modern MacBook is fantastic for learning software development. And in terms of how much memory, they call it RAM, right? How much memory you have. 4 to 8 gigabytes is the lowest end you want to go to. If you have 16, it's great, but you don't need to buy some massive 64 gigabyte machine. And in terms of hard disk storage, honestly, about 250 to 500 gigabytes is fine for your hardware, for your storage, for your hard drive. So I hope that helps. Jeremy has a really good point. He is one of our students in our game developer boot camp, and he did need a big beefy thing. That's one of those specialized activities. Making games and running games, as any of your gamers know, you have to have a beefy machine because you're asking so much of your computer in terms of processing all those images super fast. Anyway, that was a great question, Carolina. Appreciate that. All right. So what's the basic agenda here? Well, we'll have a short explanation of the Tech Academy, who we are, what we do, and then we're going to jump into writing code. You're going to get your hands dirty with it. It's fun. We'll have a brief Q&A session, and we'll give you some information about our boot camps, and we'll have a free gift for you at the end. So please stick around to the end. It's a great gift. Whole class should take about an hour, hour and a half. So who are we, the Tech Academy? Well, we run boot camps, and boot camps are intensive technology certification programs. They're designed to prepare people for entry-level positions in technology. Typically, a boot camp will last 3 to 6 months on average, and they focus on modern, practical skills, the kind of things that the moment you go onto the job, they need you to start doing right away. We've been offering these thorough, budget-friendly, flexible, tested, trusted boot camps for over a decade now. And it's been a fun journey, right? Our certification programs are cost-effective, they're self-paced, they're all online, and they're tailored for beginners. As I've said, they have no prior technical or coding knowledge. They cover in-demand skills, they're endorsed by stellar online reviews, and they're designed to fit around your personal schedule. So we can prepare you for your technology career with a well-rounded toolkit. Average cost of boot camps in America is about $13,500. Ours are under the national average, and we even have boot camps that start at like $5,300. I always like to read our mission statement. Why are we here? Well, the mission statement of the Tech Academy is to graduate entry-level technology professionals that excel in the basics of their field and thereafter have successful careers in the tech industry, and whose actions raise industry standards and surpass client expectations. We like to feel like our product is you working in tech. That's how we know we're doing our job. All right. I'm really excited to talk about this. We have a brand new service. I say brand new, it's been about 3 weeks. It's called the Tech Academy Accelerator. This is a monthly subscription program. It includes live weekly workshops with me. More about that in a moment. It includes over 100 educational videos and over 100 self-paced online mini classes in more advanced subjects. In fact, this whole thing with the accelerator, and especially the weekly workshops, is that we get to do a deep dive into complex technical subjects. There's back and forth Q&A throughout the whole workshop, not just a Q&A at the end. It's open chat and voice, so there's a dialogue throughout the whole workshop. And the topics we cover on the weekly workshop are the topics suggested by the community. And there's a whole community surrounding it, people who are at various points in their technology journey, just beginning or working engineers. And because of that, you get exposed to a lot of really cool viewpoints and experience. It's super cheap. It's only $9.99 a month. And you can actually get your first 7 days free to just try it, see if you like it. What we really recommend, by the way, there's a link if you're interested in joining this in the chat, is join. You're not going to get charged for the first 7 days. So join and attend that first weekly workshop and see if this whole thing is for you, with the courses and the videos and the workshop. See if you like it. You can cancel anytime. If you click on that link, it'll take you through to be able to apply. You'll enter your card number. You're not going to get charged right away, and it's pretty straightforward. Anyway, that's what that's all about. I'm going to pause for a moment for anybody who's filling that out and take a sip of water. They're a lot of fun. This last week, 3 or 4 days ago, I got to talk about something I've never taught publicly to any of my technology students, which is how to become an idea factory, how to create ideas on demand. In other words, how to be an exact framework for when you're confronting a very difficult problem and you've been chewing on it for a while. Like, how is it that you break through and have that aha moment and generate an idea? And it's really reliable. And I got a chance to teach that, which was really, really cool. Yes, Jeremy, become part of the nerd club. We're calling ourselves accelerators, not the nerd club, which is another point. You don't need to be a nerd to go into technology. I'm a nerd, self-professed, but that's just me. All right. So as we get ready to actually get our hands dirty and write some code, let's cover a couple of basic definitions. What's a program? Well, a program is a series of written instructions that someone can enter into a computer that make it perform specific tasks. And I kind of alluded to this earlier. We're used to using programs to get work done for us. You're going to look now at flipping it around where you're the one creating that program that other people will use. So what's programming? What's a programming language? This is what you use to make the program. It's an organized system of words and symbols and phrases, and they allow you to communicate with the computer. They allow you to write these programs. And that's what a programming language is for. There's thousands of programming languages. Now, that might seem daunting, but what's really cool is that what you'll learn tonight, you can use as an entrance point to study any computer language. It's extremely valuable in that regard. And finally, we want to cover the verb coding. What is coding? Well, this is the action of making the program. It's the action of entering in the instructions that will result in a program that other people can use to get work done. That's what coding is, right? And so code is those written instructions. And you're going to do some of those tonight. You're going to make them. All right. Now, the language we happen to be using tonight is called JavaScript. JavaScript is a really popular computer programming language. It's been around since 1995, at the beginning of the World Wide Web. And I was around. Yes, I'm old, right? And it's used both for creating, computer programs as you're used to thinking of computer programs, but it's also used for making websites highly functional. So JavaScript can be used for two real popular areas. And that's another reason that the language itself is popular. There's another technology that we use a lot when making websites and working in the web called HTML. It stands for Hypertext Markup Language. And it's really simple. It's just a programming language you can use to control the appearance of your web pages, to control what the content on the web pages look like, the text, the images, the videos, all that. You make them look the way they look with this language called HTML. There's another really popular technology in the web world, and it's related to JavaScript, right? Because JavaScript is used for web pages. This technology is called CSS. It stands for Cascading Style Sheets. Let me break that down. A style sheet is simply a little file, and in that file are some rules about how the appearance of different web pages should look. That's all that's in the file. Now, cascading is really cool. It means you can just take that one file with those little rules about the way things should look, and you can make the rules in that file apply to some or all of your entire website. Why is that cool? Well, let's say you want to change something across your whole website. You can go to that one location and make the change you want, and it cascades. It ripples out through every page in your website. So it's pretty valuable. When you look at these three things, we call them the holy trinity of web development, because with JavaScript, HTML, and CSS, you've got the primary skills of working on websites, which is kind of cool. So this, again, is a JavaScript class. There's lots of languages, but that's the one we're going to use. All right. Now, I mentioned that I was going to give you a tool that would be helpful in using any computer programming language. And this is it. These next 5 things I'm going to teach you are the most important data in this entire class. I would argue, now having like decades of experience in helping people to understand technology and become computer programs, that understanding these 5 things is one of the most important things you can ever learn if you're interested in working in technology. So with all that said, what are these 5 elements of a program? Well, for you to create a program that's going to be useful at all to human beings, right? It needs these 5 things. And the first thing it needs is an entrance point. All that really is, and it sounds super simple because it kind of is we need the first instruction. When you click on an icon on your computer that says start the following program, like Microsoft Word or Diablo or whatever game or whatever program you're using, when you click on that, what it tells the computer is, hey, go to the first instruction, do that one, and then keep on going in the list of all the instructions that you have for that program. So you need a place to start. Again, it sounds really simple because it is, but it's valuable for another very, very specific reason. Remember, we're talking tonight about the idea of, instead of being the person using the computer program, you're looking at the idea of being the program, which means a lot of the time when you are on the job, you don't get to start every project from scratch. You have to work on existing programs. And when you're doing so, it can be a little daunting at first because they can be pretty big, complex. They have lots of files, lots of things going on. And so knowing that every computer program has an entrance point, it has the very first instruction, knowing that is really valuable because you can go into the program and find that first instruction. It's usually pretty easy. And when you find it, now you can start to follow along through the code in that program and see what it's doing. I'm sure you can imagine if you were looking into the code and you started somewhere in the middle of what the program was doing, it's very little context. It's much harder to understand. So that's what an entrance point is valuable for, among other things. So that's one element of a computer program. The next element of any computer program is called variables. Variables are pieces of data the computer is keeping track of inside your program. But most importantly, it's pieces of data your computer is keeping track of that can change as your program runs. A typical example might be if you have a program that's centered around keeping track of the clients for, say, an e-commerce store, that while the program is running, clients could sign up and some clients could leave. So just knowing the total number of clients you have, that would be a nice variable, wouldn't it? And it needs to be able to change as the computer program runs. If you built, I know this would be absurd in the modern world, but let's say you built a program designed for a store and you only allowed it, when you built it, it was preset, it can only have 100 customers. Like, honestly, let's say you were in a small town and you start this little teeny business. You're like, man, I live in a town of 30 people. I'm making all this up as I go, right? I live in a little town of 30 people. There's no way my town is ever going to have more than 100 customers. And so you hire a computer programmer and you tell him or her, hey, listen, build this thing to be able to manage, records of my customers. And I'm only ever going to have, a few customers. So you can set the maximum customers to 100. And he's like, okay. And he makes your program that way. And then something changes and the town gets big and you have 101 customers and your computer program breaks. It can't store it. It was predefined what the maximum number of customers was. Now, I know that sounds absurd, but in the early years of creating programs, this wasn't a given and people made mistakes. They would incorrectly assume the scope of a program they were making, the kind of data it was going to use and how much it would change, and they'd think it wouldn't. And they'd build a program, and then suddenly conditions change, and the program had limited use to them. And they had to go in and change the whole program around. So now we use variables. So they're important. Now, before I go on and show you the other ones, I want to stress that I'm not showing you these in the order in which you'll actually put them into a computer program. You can use them at all different places in a program. They're just the building blocks that you use when you make a program. All right, next one. Your program must have a way to do control and branching. Let me explain. Control is directing what your program does if there's more than one option, which probably shouldn't be a surprise to you. We use computer programs to make decisions for us all the time, right? If you're ready to make an order on an e-commerce site and the person has entered a coupon code or hasn't entered a coupon code, I'm sure you can see you would handle that two different ways, wouldn't you? Well, you need a way to be able to make that decision, to check, does a coupon code exist or does a coupon code not exist? That is control inside a program. But then you also need, okay, there's more than one thing to do. You've got to build those things to do. They call those branches. Just different sets of instructions. And based on the decision in the control area, you'll only do one of those two things, as an example. I'm sure you can see that a computer program that didn't allow you to do this would be of limited usefulness because you wouldn't be able to react to the user's data and go, oh, well, based on what the user told me, I've got a few different things I can do. No, you'd have one thing. Sorry, everybody gets the same experience. Not a very useful program. And so this is a fundamental element of a computer program. Next one, and this is magic. It's called a subprogram. Think of it as a program within your program. These developed very simply. Let me tell you how these developed, because there's nothing magic or fancy about it. It simply was this. Back in the very early days, in the 50s of last century, when people were first figuring out this whole computer programming thing, what the programmers would find is this. They'd be building programs. Let's say they're doing like programs for the insurance industry, where you involve lots of calculations and probabilities and statistics and all that kind of stuff, right? And they'd find that they were entering instructions into the computer for their program, and they'd find that over and over again, there was a set of maybe a handful of instructions they would have to do that were unchanging. Every single time they needed that exact type of action to happen in their program, they'd find themselves entering the same, say, 7 instructions in a row over and over, maybe 200-300 times. And like, 1, this is a waste of my time. But 2, and more importantly, let's say the way those 7 instructions worked changed a little while later, and you wanted to change those instructions a little bit. Now that program has got to go back through his or her program and find every one of those 200 or 300 instances in which they use that exact set of 7 instructions. And they've got to change every single place they used it. That's horrible. No one would want to do that. And it's very easy to make errors when you're doing stuff like that. So what do? They invented this little thing called a subprogram, where you could take, in this example, those 7 instructions and just give them a name, package them up, and call them, subprogram A. You like the way I name things? It's really creative. They would call it subprogram A. And then they go, and in their program, every time they needed that particular set of 7 things to happen, they wouldn't write out all 7. They'd say, just do subprogram A now, and when you're done, come back to where you're left off. That's the simplicity of it. But it's magical what it does. Because 1, you don't have to type the same things over and over again and possibly make mistakes. And 2, if the way those 7 instructions work needs to change in the future, you go to one place, that little package called subprogram A, and you make the little change. And now that change applies everywhere else in your program. So subprograms are awesome. Good. The last thing that any computer program needs is it needs an exit point. It needs a last instruction. Now, we talked about why do we care about the last instruction? Here's why. Your program is not operating in a vacuum. It's operating on a computer, and that computer is doing a lot of things to help your computer program be able to function effectively. At the very minimum, it's allowing your program to have access, say, to the underlying folders and files. But it's also reserving areas inside the computer's structure. It has a thing called memory where it keeps track of data. It's reserving part of that memory just for your computer program to use, so that no other computer programs can mess up the data that your program is using. Well, if that memory is being allocated or reserved for your program, it's less memory available for other programs. And so the computer that your program is running on needs to know, hey, we're done running this program. So that means that I can release all that memory and make it available to other programs. There's lots of other concerns, but it's one of the biggest ones. So I hope you can see that for any program to really, like I said, be of value to people, it needs to be made up in some way of these 5 things. Now, we're going to build most of these tonight using JavaScript. But again, this is a framework that you can use in the future to help figure out how to study any computer programming language. When you're studying a new language, the first thing I recommend is go to that language and find out, how does this language do these 5 things? And if you've learned that, and it can take you a day, if you learn that, your comfort level with learning the more complex things that language can do just raises dramatically. So that's the 5 elements of a program. All right, now we're going to get to coding. To do that, you need a place to write these instructions, and we're going to use a really cool platform online. There's a link that just got dropped into chat. I'd like you all to click on that, and don't mess with anything. Just look at it once you open up that tab. It'll look something like the one you have on the left here. And now, once you've got that open, here's what we want to set up. I want you to be able to have, if you've only got one monitor, which probably the majority of you do, it's just one screen to look at. If you've got 2 screens, that's fine. This will be much easier to set up. But if you have one screen, I want me on the left and your code editor on the right. In other words, I'm going to switch to a code editor in a moment here inside of Zoom. And I want your Zoom application to be on the left and that tab with the code editor to be on the right. So you can see back and forth and type exactly what I am typing without having to try to memorize it or whatever. So to do that, sometimes Zoom tries to resist you resizing it and moving it around. It's sometimes helpful to click on the word Zoom meeting, and this little button here called Restore will appear. If you click on that, your Zoom window gets kind of small and you can resize it and move it around. As far as your browser, where you've got this code editor in, it'll animate it, right? You've got a tab and you can pull it to the side and make it smaller. So do that, and then we'll get to coding. All right, now I'm going to switch here, and I'm going to switch to my code editor. And I think on this one, I just need to do a plus, 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 make it a little bit larger so everybody can read it. So let me explain kind of what I'm looking at here, okay? On the left here is where you put code. On the right is the output. Seems pretty straightforward, and it is, okay? Now, the first thing I'm going to show you is the actual computer program that we're going to run. Don't try to type this out. That's not the intent here. So I'm going to show you what the computer program is. So we have this memory game. You'll get all this code tonight. For right now, I'm just going to copy all that, and I'm going to paste it in here, and I'm going to run the game. And you can see, if you look at the bottom here, I've got 8 attempts to try to flip over these cards 2 at a time and memorize them. So I'll click on this one. It's a spade. Now I'll click on the one next to it. No, that's a heart. All right, let me click on this one. There's a spade. Oh, I remember. That's a spade there. Okay, I got a match. Look at that. I've only got 6 attempts remaining. Well, let me see what this one is. Oh, that's a heart. Oh, I remember that's a heart. Hey, I got a match. Let me try down here. I got a diamond. Let's do next to it. No. There's a diamond. Hey, there's a diamond. And of course, these two match. Ooh, with 2 attempts remaining, I won the game. And it says you win, play again. Okay, good. I know it's not a super complex game, but it's kind of cool. The cards will be laid out randomly every time, and it's a playable game, right? Now, what you're looking at over here on the left is all of the code that makes that game work. And if right now that looks super confusing to you, I do understand. By the end of the class, you'll at least be able to look through this code and identify how we're using each of those 5 elements, and you'll be able to follow along to a certain degree with the logic that's being applied to make this game. If someone who's a graduate of our boot camps will be able to read through this thing and understand every single aspect of it, right? But you'll get the fundamentals today, okay? All right, so that said, let's get back to helping you guys to do some coding. I just reverted. And David, no, we should not get on W3 Schools. Just click on the link. It says bit.ly/Tech Academy JS editor. It's right above you in the chat. All right, and that will show you. You'll get exactly what I'm looking at right now. Okay. All right. So the first thing I want you to do is this. If you look at this script word here and this /script word right here, it turns out that what you're looking at is the whole thing is a web page, but it's only this little section in here I've highlighted. That's where the code goes on your web page. Remember, I said JavaScript can be used to add functionality to websites. Well, this is how you do it. One of the ways you do it is you put this thing called a script right inside your web page, and in there, you can put JavaScript. You can write code inside there. And that's what we're going to do. So I want you to highlight all that stuff and delete it. And so what you should be left with right now is script and /script with a little bit of space in between. And it's that space in between where we're going to start actually writing some code. So give me a moment here and I will pull up the code we're going to use. All right. Okay, so here's the first thing I want to do is I want to be able to make something appear to the user just because I told the computer to do it. And we're going to use a little thing that a lot of the time, as you know, people that use the web all the time, we might not like. It's called an alert. An alert is what you saw right at the end of the game. When I won, it was a little message box that popped up around here and said, hey, you won. And continue or whatever. And that's called an alert. Now, in JavaScript, there's a special command called alert. So I want you to type that, A-L-E-R-T. Well, it would help if you put your cursor over there, Eric. So A-L-E-R-T, all lowercase. And this is an actual instruction in the language called JavaScript. Now, for this instruction to work, JavaScript does something it's very common in almost every computer programming language. Very often, if you're going to ask for a specific instruction to occur, that instruction needs some data to actually do its job. And we call that action of giving it the data that it needs, passing in the information. We're going to pass in some data. The way you do that in JavaScript is without a space after the word alert, you do an open parentheses. And now we're going to put whatever text we'd like to appear in this box that's going to pop up. The text should be in between double quotes. So do a double quote. It's right next to the enter key, but you have to hit shift for it. So it's a double quote. And we're going to type what we want. I think we should just type hello. Make it very simple. Type hello. And then do another double quote to tell the computer, I'm done giving you the text. Everything inside the double quotes is the text I'd like you to display. And the double quote, whatever's in between those, that's how you indicate the text. But we also have a parentheses at the beginning, and we need one at the end. So give me the other side of the parentheses, a closed parentheses. At this point, we're almost done. The one last thing you need to do is, it's in JavaScript, it wants to see a semicolon to tell the computer, hey, this is the end of the current instruction. Do this, and then go to the next one. So you do a semicolon. And now we have a JavaScript instruction. We're using the JavaScript command alert. We're giving that command. We're passing in some information. It's the text, hello. And we should be able to run this. And look, an alert pops up. That's all it says. It says the text that you put there, but you made it do that. Now, we also have shown you the first instruction in JavaScript. Most languages are this way, but not all. In JavaScript, for any particular chunk of JavaScript, the first thing that gets done is the instruction at the top. There's no surprise to that at all, okay? But let's do two instructions. Oh, you have to click OK to get that alert to go away. Let's do another instruction. We'll do another alert, A-L-E-R-T, but this time we're going to say hello again. So give me your open parentheses, double quotes, and we'll type hello again. Give us an exclamation point. Right now the computer's friendly. Then do a double quote to show to the computer I'm done giving you the text to use. Do an end parentheses to tell the alert, hey, everything inside these parentheses, the alert is supposed to take all that information. You're passing that information into the alert instruction. And it's done. Now, give me a semicolon to say we're done with the current JavaScript instruction. Now, when you run this, you'll get one pop-up after the other, or one alert. There's an alert that says hello. Click OK. There's another one that says hello again. So we've got two instructions. Great. Nothing complex here. Now, let's have a little bit of fun here, okay? Let's start to look at variables. So one of the things we would want to know is, of the 8 cards that can be chosen, we want to know, actually, we're considering 2 cards at once. We flip over 2 cards, right? We have card 1 and card 2. There could be any one of the cards that are on the table, but we always want to compare card 1 to card 2. And we're trying to find out, hey, do they have the same symbol? It's pretty simple. So we know that every single time the user goes through a turn, that the data of what is card 1 showing is going to change. It could be a club or heart or a spade or a diamond. So this is a perfect place for a variable. So let's make a variable called card 1. And it's going to hold data of what's the symbol that's showing. Pretty simple. Well, in JavaScript, to make a variable, you just use the word var space, var, variable. That's what var stands for. And the word that comes next is the name of your variable. You're going to name it so you can refer to it later. You're going to refer to it later so that, one, you can find out what data is stored inside it, or two, you can change the data that's stored inside it. But think of this next thing you're going to type, this name, as the name of a bucket. Think of a variable as a bucket. And inside the bucket is the data that you care about. So there's the name of the bucket and the data inside it. Those are two separate things. So we're going to call this one card 1. There you go. We have card 1. We've made a variable. But now we need to give it some data. What's inside there? Well, let's say it's a heart. So to put data in the bucket, right? The actual word we use is to assign a value to the variable. We need to use a symbol like this. It's just an equals. And the way JavaScript works, lots of other languages work this way as well. The way JavaScript works is if you have a variable you've made to the left of that equals symbol, then whatever data is to the right will be stored in that variable. So let's store the word heart. So put it in double quotes. We're not going to make it, I'm not going to make things really complicated and try to have you store the image of a heart. That's way beyond the scope of what we're doing right now. But we know it means heart, and that's enough for the logic we're trying to learn tonight. So once you're done with that, get yourself a semicolon and hit enter, and we've made a variable. Now, I know that doesn't seem super awesome, but it is kind of cool. There's two separate concepts you just learned. The first one is just the making of the variable. Everything to the left of this symbol, where you use the JavaScript instruction var, and then use the name of your variable. Everything to the left of that is called declaring a variable. And what actually happens inside the computer is the computer, when it performs this instruction, it finds the location in its memory devices. There's little devices inside your computer that store data. They're called memory, right? And it finds a location. It's an actual physical location with little electronic components in it. And it gives that little location a name. In our case, card 1. That's what happens when we do the part of the instruction that's to the left of the equals sign. And then the computer does a second thing. It says, okay, having, found a little piece of the memory device inside the computer and having given it the name card 1, now I'm being told to store some information in that location. And the information we're asking it to store is the word heart. So there's two separate things that occur on this line. Create the variable and then put data in the variable. Fine, so we have a variable. Can we make use of that? Yeah, what if we wanted to let someone know what symbol is on card 1? Now, in our really cool game, what we do is we flip the card over with a nice little animation. For right now, to keep it simple, we're just going to make an alert pop up that says card 1 is a, and then we'll have the symbol. So let's do an alert, A-L-E-R-T. Remember, what you're going to put inside this alert goes inside parentheses. So we'll start with the open parentheses. And now we're going to do something kind of cool. We wanted to say card 1. Actually, let's keep it lowercase just to be consistent. Card 1 is a, hit a space, and now follow me here. Remember that at any point in time while someone's playing the game, the symbol on card 1 could be different than it was even a moment before. And this is where variables come in helpful. We can end off the text that we're giving it. So make sure you put the space and then do a double quote again. And now we're going to tell the computer, hey, print off what I just told you, which is the words card 1 is a. And when you're done printing that off, then print off the data that's currently inside the variable card 1. You're not going to print off the words card 1. You're going to print off like, You're not going to print off the name of the variable. The variable is called card1. You're going to print off what's the data inside there, because that's what we care about, is the data that can change from moment to moment. The way you do that in JavaScript, you can do a space and then the symbol plus. And the way JavaScript works is anything after that plus just gets included as the text that's going to be used. In this case, we're going to use the text to show in a little alert. But obviously, lots of computer programs use lots of text for lots of different reasons. And so the plus is a special word for what it does. Ready for a fancy $5 word? It's called concatenate. Concatenate means to stick two pieces of text together. That's all it means. So the plus isn't math right here. To JavaScript, right now, that symbol means concatenate two different pieces of text, or stick together two different pieces of text. But we're not going to give it actual text. We're not going to give it anything inside double quotes. Instead, we just give it the variable, card1. And the computer will not try to print the text CARD1. What instead it will do is, like I said, find the value that card1 currently holds and put that stuck together with the earlier text. And then we can do an open parentheses and a semicolon, and we're done. Let's run that bad boy and see how it works. Well, there's our first alert. We expected that. It says hello. Click OK, and the second alert pops up. Hello again. We kind of expected that. And the third one says card1 is a heart. Hey, that worked. Well, click OK and make it go away. Let's say a moment later, card1 changes. It's the next turn. And they click on a different card. So type card1. We're going to give it a different value. We're going to put something different in the bucket. Do a space and then an equals. And this time it's going to be a spade. We've changed the value. Well, I'm not going to write this one. I want you to take a moment and just try and see if you can do it yourself. Make an alert pop up that shows this new value. I can give you all a minute to type it out. And if you can make it properly, do the fourth alert that says card1 is a spade. If you can make it do that, drop me a 1 in chat. Good job, David. That's fast. And drop a 2 if you threw an error. Some sort of weird, funky error message appeared. Good job, Carolina. That's awesome. And by the way, if it's actually Carolina, tell me yes. If I'm saying it wrong, like maybe it's Carolina, tell me no. Oh, no, it's Carolina. All right, got a bunch of 1s. People are getting it right. Awesome. Thank you, Carolina. I appreciate it. Okay, good. So I'm going to do it as well. It's just alert, parentheses, card1 is a plus card1. And let me see if I didn't make any typos. There's my hello again. My card1 is a heart. Now card1 is a spade. Okay, good. Awesome. Excellent. Everybody got that right. Good. So I hope you can see the value of a variable. We need to keep track of a specific thing, but that thing can change as the computer program runs. All right, so now let's get into this whole control and branching thing. What we're going to explore is how would you compare whether or not card1 is equal to card2? Because you're going to do one of two different things, depending upon whether they found a match or they didn't have a match. Pretty sure that would make sense, right? Good. So the control instruction that we're going to use is an instruction that's common in almost every single computer programming language. It's called if. Just type if. Oh, well, I had caps lock on. Sorry, slow case. Now, this next part is really, really, really important. Don't write anything else. Just listen for a moment. We used a built-in instruction several times called alert. And we talked about the idea that this built-in instruction is part of JavaScript. We talked about the idea that in order to do its job, this instruction needs some information. Now, what it will need varies based on what the instruction is. In this case, this instruction just needs some text data. But the if statement needs something totally different. What the if statement needs is a condition that's either true or false. These are yes/no questions. There's no maybe. There's no ambiguity. It's like, in America, are you over 21 or not? If you are, you can purchase alcohol. If you're not, you can't. Now, I know that there's some military regulations and maybe people under 21 can buy alcohol. You get the idea. There's no vagueness. Now, there might be in Kentucky where they don't care how old you are to buy beer, but that's a separate thing. It's a yes or no. That's all it is. That's what a condition is, something that can be looked at, and the computer is capable of figuring out whether it's true or false. That's what a condition is. And so we have to give this if instruction, we have to give it a condition. We have to give it something that it can check to see whether it's true or false. And what we want to look at is whether card 1 is equal to card 2. Oh no, you say, we don't have a card 1 or a card 2. You're right. So I want you to make a little space above the if, make a little line there, and let's make a variable called card 2. I want you to make it a spade. You should be able to figure this out yourself. I'm going to give you a moment. If you think you've got it right of making a variable called card 2 is equal to a spade, throw a 1 in chat. Good. David, I want you to paste that instruction into chat so I can look at it. David was the first person. Nathan was hot on his heels. Good. So yeah, David, go and copy just that one instruction you wrote and paste it into chat. Oh, good. Var card 2 equals spade. You know what? It's so good, I'm actually just going to copy it out of your chat. Look at how I got David to do my work. Thank you, David. Appreciate it very much. Yes, you've created a variable, and we know you've created it because we use the instruction var. We called it card 2, and we made it equal to the text content spade, S-P-A-D-E. Good. So now we can actually start to build this condition. Go back down to that bottom line, the if. Don't put a space after it. Instead, we're going to give it information, and we've already learned if you want to give one of these instructions, if you want to give it information, you put it inside of parentheses. So give me a parentheses. By the way, before we go any farther, I just want to teach you a little bit of a smart practice. If you know that you're building something inside of parentheses, and you know from long experience that it's really easy to forget to put the matching close parentheses, I like to teach people to always type it and then go back 1 so they're right in between the parentheses. In fact, some code editors, if you type the open parentheses, they'll even automatically generate the closed parentheses for you to prevent you from making mistakes. So go ahead and do that. So what do we want to have inside here? Like I said, we want a condition. We're going to start actually with how you form a condition. And you do it with checking whether or not two things are equal. That's a very common way to do it. There's other comparisons you can make, but the most common thing is, are two things equal? And that's what we're doing here. We want to know if we found a match. We want to know if the symbols on two cards are identical. We want to check for equality. Well, I want you to do a space, and then there's a special symbol you're going to type. It's 2 equal signs in a row. And then, oh, I didn't do an equal sign. And then I want you to do another space. Now, this is not the condition. We are absolutely not done with what goes inside these parentheses. But I'm going to make a point here. In JavaScript and many other languages, the way you check whether two things are equal is you put them on either side of this double equals symbol. Jeremy, I got your message. I'm sorry to hear that. Appreciate you for popping back in. The whole recording will be made available within a few hours, if not tomorrow. So you'll be able to watch the whole thing, Jeremy. And I hope that all goes really well for you. Thank you for letting me know what's going on. So we're building a condition. We're saying we're going to check something on the left and something on the right. Now, I want somebody who is not a current coding student of ours to drop into chat what they think should go inside the parentheses. Drop it in the chat if you think you know what I'm going to type here inside the parentheses. Yep, card 1 equal to card 2. So let's go back here. So yeah, type it CARD1 and then go after the double equals and the space and type CARD2. Now we're not done with this whole thing, but I want you to look at that for a second. Just stop and look at that. That reads like common sense, doesn't it? That reads like English. If you've got intelligent names for your variables, anybody looking at your code later on would be able to figure out the purpose of this part of our program. Oh, we're going to check to see whether or not we've got a match. Good. All right, good. Now, this part's really important. We need to put down in code, what do you do if this condition is true? And the way you do that in JavaScript is you hit a space, and we put the instructions to be performed only if this condition is true. We put them inside curly brackets. David, that's close, but you don't need the then. All you need to do is use an open curly bracket. Now watch this, watch very carefully. That's an open curly bracket. It's above your enter key and to the left a little bit. Watch this, hit enter twice, and then do the closed curly bracket. Now the reason I'm doing that is because I want to show you the structure JavaScript is looking for. What JavaScript is going to do, follow along really closely here. The computer is going to do all of these first instructions up here, right? It's done all of these, and it's going to get here, and it's going to first grab this, and it's going to figure out, is this condition in fact true? And if it is, what JavaScript's going to do is it's going to move forward, and it's going to find a curly brace and a matching closing curly brace. And only if the condition is true will it do what's inside those curly brackets. So put your cursor inside the curly brackets, and we're going to start to put the instructions there. There's only going to be one. All we're going to do is pop up an alert that says, you found a match. That's all we're going to do. Now, don't start typing it yet. Here's another little tip. You could start, don't type anything, just watch me. You could just start typing ALERT right here. But to make your code a little more readable, what you'll do is you'll hit the tab key and you'll jump over 3, 4, 5 spaces, whatever tab is set to. And then you'll type, now do follow along with me now, hit the tab and then go ALERT. Then do your open and close parentheses. Go back inside the closed parentheses. I'm using that little smart practice I just talked about a few minutes ago. And here, we want to tell the user they found a match. So put in double quotes. And by the way, I also like to do a double quote, followed by another double quote, and move the cursor in between them. And this way, you're making sure you don't forget anything. It's really easy to make these little teeny, gnarly, stupid mistakes. I've done it a million times. So I've developed these little habits over time, and I recommend them. So you've got your cursor in between the double quotes, and those double quotes are inside of parentheses. You're ready to display, to type the message. I just want to say, you found a match. But you know what I'm going to do? I'm actually going to spell it correctly. There you go. And because it's exciting, I want to put an exclamation point or 3 at the end. So do all that. And that's the only thing we're going to do. That's the only instruction inside of these 2 curly brackets. That's all we're going to do if card 1 equals card 2. And you should put a semicolon at the end so that JavaScript knows you're done with that instruction. So I want you to put into chat what you think the final pop-up is going to be. What's that final pop-up going to say? Yep, you found a match. Oh, Ashveen, that was so close. There's 3 exclamation points. David, you did the same thing. I know I sound obnoxious in that, but there's a little bit of a lesson there. It's a tiny lesson. I'm not wanting to make any of you wrong. You got the right answer, right? Here's the lesson is most of the time when your computer program isn't doing something that you expected it to do, when you're throwing an error or you're getting improper behavior, almost always it's 1 or 2 characters that are wrong. And so after you've been coding for a while, you really develop the practice of being able to scan through codes line by line and compare them to what you expect them to be 1 bit at a time. And you get very adept at spotting the thing that doesn't make sense, the thing that isn't a match. Good job, Nathan. Nathan says, yep, missed a closed quote. That's spot on. Good job. It's spot on. Look, you probably see me make little mistakes tonight in typing things out, or I actually forgot to make the variable called card2 before we started talking about the if, right? Here's another point I want to make is you may have gotten the idea from, say, watching different videos on YouTube or other sources where people are teaching coding or doing tutorials. Maybe you've gotten the idea that for developers, it goes really smooth and you rarely make mistakes. That is ludicrous. We make mistakes all the time. So do not think that you're any different or put yourself down at all. We do it all the time. You're just at the beginning of your journey. So you maybe make a few more. But we all do it. We all do it all the time. All right, good. So this is great. Let's go ahead and run this. And we have number 1 says hello. Number 2 says hello again. Number 3 says card 1 is a heart. 4 says card 1 is a spade. And now you found a match. Okay, good. All right. Well, fine. That's good. But Erik, what if they don't have a match? I'll show you how to handle that. You handle that with another handy instruction in JavaScript. Now, this one's kind of weird. This instruction can only be used if we've just done an if. So go to the end there, hit a space after the curly bracket, and type else. And that's it. You can't just have else without an if right prior to it. Because it doesn't make sense logically, does it? You're comparing 2 different things. In other words, you've taken this condition and you've said, all right, I'm checking for equality. I've provided inside of these curly brackets right here what to do if the condition is true, what to do if they are equal. Now I need to provide what to do if it's false, if they aren't equal. And you do that by giving the command else, and then big shock, hit a space, and give me 2 curly brackets, just like that. Because now you got to have a set of instructions that are demarcated, that are marked off, that are only to be done if the condition up here isn't true. So go back inside those curly brackets right there where my cursor is, and then give a tab. It's just, the tab isn't important to the computer. It's just important to the reader of your code to make it a little easier to read. That's all. Okay. So this is simple. Alert. Give me your parentheses. Give me your double quotes. And then, sorry, dash, no match. Type that in there. And I might even go sad face. Yes, I'm a nerd. All right. So that's great. We have a different option, but how do we test whether or not this works? I'd like someone to write into chat, what do you think we could do right now to see whether or not this code that we've written, this else and the instruction after it, what can we do to see whether or not it works? Ooh, good catch. Reem says, where's the semicolon? Right there. James hit the nail on the head. Other people kind of described it decently with little code examples and everything. But I like the way he said it because his answer aligns with the spirit of what we're trying to do. His answer was choose another suit for one of the cards. Other answers were equally valid. Changed variable, changed the variable character 2 equal to XXXX. Those are totally correct answers. They would all result in the alert that says, sorry, no match. But the one that fits with the spirit of the game is what James wrote, choose another suit for one of the cards. So let's take card 1 and we'll make it a diamond. Do that change and then run it and just see if the last alert tells you, sorry, no match. Look at this, sorry, no match. Wah, wah. All right, now, yes, this is a bit of a silly example, except it's not really. While we've simplified it, this is the exact comparison we're going to need to make every single turn in our game. We're going to need to check for equality between the two cards that the user flipped over. And based on whether they are or not equal, we're going to have to take one of two completely different paths. If they're equal, then we're going to leave the cards face up. And if they're not, we're going to turn them back over again and start a new turn. So we need two different branches. So again, this is the control instruction where we do if and check a condition. That's a control instruction. And the branches are inside these curly braces and inside these curly braces. That's the branches, control and branches. Okay, good, awesome. Now, last thing we're going to look at is subprograms. So let's just stop for a second and step back and let me ask you a question. You're the designer of this game. You know that you're going to give the user 10 attempts to find matches. And you know that there's an exact sequence you need to do each time. You need to display to the user the so far unmatched cards. You need to allow the user to select two cards. You need to, and this is the important part, check whether or not the cards that flipped over matched. And then you need to handle whether it was or wasn't match, handle it again. If there was a match, keep them up. If there wasn't, flip them back over. And then you need to do the same thing over again. Display the unmatched cards. Have them select two cards. Check for equality. Leave them up if they match. Turn them back over if they aren't. And then do the same thing over and over again. I don't know about you, but I do not want to write that series of instructions out 10 times in a row for the 10 turns that I'm allowing my user. This is where subprograms come in. Now, we're not going to build that whole subprogram of display the cards, have the user select two of them, check for equality, handle it based on whether it's equal or not, and then start over. We're not going to build out that whole sequence. We're just going to build the one we've already built. We're going to take this little check right here. Did we find a match? And we're going to turn it into a subprogram. Sound fun? I think it's fun. So to make a subprogram in JavaScript, the first thing you need to know is they don't call them subprograms. They call them functions. In fact, for a lot of computer programming languages, that term subprogram is not the term that ended up being used over the years. They've been called functions. They've been called methods. They call it subroutines. Some languages do call them subprograms, but it all amounts to about the same thing. We're going to take a set of instructions that we're going to need to be used repeatedly. We're going to give them a name, and we're going to set them off to the side and only use them when we need them. So let's do that. You do that by using the JavaScript word function, F-U-N-C-T-I-O-N. Notice how the code editor turned it blue to make it really clear. Hey, this is a special word. Hit a space, and now we're going to give a name for this function. We're going to call it check match. Notice how I capitalized the C and the M. So do it exactly the way I did it. You don't have to do it that way. You could call this function whatever you want. You could call it duplicate. You could call it did they find a match. You could call it are identical. You can call it whatever you want. I called it check match. Good. Now, hit a space. We have so far told JavaScript we're creating a function. We've told JavaScript what the name of the function is. I made a mistake. Go backwards. No space afterwards. Now, guess what? We have to do something remarkably similar to the way the built-in instructions in JavaScript work. The built-in instructions, if they need information to do their job, they have to go inside parentheses. Well, this function needs information to do its job. It needs the two things that it's going to compare. It needs the value of card 1 and it needs the value of card 2. So right after the word check match, give yourself an open and close parentheses and go back one, because right inside there, we're going to give it the two things it needs, our two variables, and they're going to be separated by a comma. Card 1, comma, card 2. Shivakanta, I see your error in there that you're running into. We'll try to pick that up if we have time at the end. Okay, good. So right now we've done some of the most important parts of creating a function. We've given it a name, and we've clarified what information we're going to give it when we need it to do its job. But now we need to tell it what to do when we ask for it to do its job. Not surprisingly, what you do goes inside curly braces. So give me a space, an opening curly brace, hit enter a couple of times, and give me a closing curly brace. And now go back up in the middle. It should start to seem intuitive now. What goes inside these curly braces is the instructions that will be performed when we ask for the check match function to do its job. So do a tab, again, just for readability's sake. And this is going to shock you. We're just going to copy and paste. So follow very slowly here. I want you to copy all of this. Nothing else. Copy all that. Okay. Then go down inside the function and make sure I copied it. Okay. Now, I actually want you to erase the tab. Okay. If you have a tab there, just erase it. And now paste that in. And now watch this. Again, I'm only doing this next part to make this code easy to read. I want you to highlight, go very carefully, just the part that you pasted in. You see that? Highlight all of it. Don't highlight the very bottom curly brace. This is not programming. It's just, I'm showing you this so that, I'm doing this so that it'll be easy to read. And while it's highlighted, hit the tab key and it'll all move over one. I want you to see how that makes it easier to read. We have this curly brace right here. We have this matching one way down here. And everything inside is the instructions we want to be inside this function. Fine. If you follow along, now we're going to use that function, because we would want to do this step over and over again. We would do it as many as 10 times while someone's playing the game. Maybe they win the game before, but we're going to give them 10 attempts to find matches. So we would call on this function. That's what's called calling the function, asking for it to do its job. We would do it over and over again. So let's have a little fun here. And we're going to set up a scenario. I want you to say that card 1 is a club. Gotta spell it right. So do that. And then make card 2 a heart. And now, this is the important part. I'll wait for you to type that in. Now we're going to check for a match. Instead of typing out this whole business right here, we can simply type this. We type the name of the function we want to use, check match. Make sure you spell it exactly the way you spelled it up above. We type the name of the function we want to use or call, and in parentheses, we put in our 2 variables, card 1, comma, space, card 2. That's all it takes to call on that function to run. And when you run this, the final pop-up should probably say no match. Let's run it. There's the first pop-up. Hello. Hello again. Card 1 is a heart. Card 2 is a diamond. Sorry, no match. But this last one, click it. It says, sorry, no match. So you can do that over and over again every single time the user takes a turn. All right, leave that for just a second in case people ran into an error. And now I want to show you, again, what the whole actual program looks like. You're going to get a copy of this code. Don't worry. I got to learn to actually copy stuff. You'll get all this code. Now, this is the full code. You can see if I run it, it displays the cards. This is the action we were checking, by the way. Flip over 1, flip over 2. And right there, as soon as I flipped them over, we did the comparison. The computer did the comparison. That's what we were building, a simplified version of it. But let's look inside here. I want to show you something kind of cool. Let's go to where the script begins. Look at that. Script begins right here. And it goes all the way down to here, end script. Everything in between there. This is our program. By the way, the // and then green, those are called comments. They don't make the computer do anything. They're just there for you and other people to understand your code better. But look at that. A constant is another type of variable in JavaScript. It's way beyond the scope of this class to explain why it's called a constant. And then let is another way to make a variable. Again, beyond the scope. But these are just variables. A variable called symbols. A variable called attempts. I mean, these variables, they make sense, don't they? But then we also need functions. Here's a function to set up the game by creating cards and arranging them. It's called function setup game. Notice this function doesn't need any information to do its job. So there's nothing inside the parentheses. And then there's a bunch of stuff inside the curly brackets. Here's the top curly bracket. And let's go down. There's the bottom curly bracket. Whenever we call the function setup game, where is it? Everything in between there is what's going to happen. And you can follow along and probably make some sense of what it's doing. At least you'd know where you were supposed to look. There's another function down here that handles what we kind of were simulating, the card flip action. We've got a check for match function. Ooh, we have a check for match function. Look at this. This is kind of what we were doing. Now, this is all kind of complex. And it uses another symbol we didn't teach, which is JavaScript has a true equality thing it can do with 3 symbols. Again, it's beyond the scope, but look at the logic here. You can see we have an if. We have some sort of condition that's being checked inside the if. We know that inside here is what we're going to do. if they're matching, and we know this is what we're going to do if they don't match. You can follow the logic. And there's more in here. Disable cards that are matched. That makes sense. Disable them, they're matched, so nobody can click on them. So you can follow along most of the logic. Now, Regina, can you drop the link to that full JavaScript memory game right there inside? There you go. You can have that code. You can run the game. You can play it. It's kind of fun, actually. And here's a cool thing before we move on. It might be fun to try to make this game include, like, take fewer turns to win, or make it include 5 symbols instead of 4. You have to make up a symbol because a modern card deck only has 4, but you can make up a symbol. Try to make it include 5 symbols and therefore 10 cards. That would be a fun challenge to do. All right. So I've tried to watch a lot of the questions. So in terms of Q&A, I'm just going to look and see if there's any more. Okay, good. Shrivakanta, I wouldn't worry too much about a little syntax error. They're always going to happen. And we don't have time to debug the specific one. Okay. But you could go back, watch the video, and follow along with every single character, and you'll find exactly where it was that it stopped working. All right. So stick around for the free gift. We'll have that in just a moment. I want to say a couple of things about these boot camps that we offer, because there's a lot of them. When I say we are, quote unquote, a coding boot camp, we're not one, we're 12. We have 12 online boot camps that cover a wide range of technology subjects, from artificial intelligence to computer programming, website development, cybersecurity, design, data science, video game development. We've got a video game, one of our students at our video game boot camp here, and even mobile app development. In fact, we have more certification programs than any other coding boot camp on earth. Our boot camps are self-paced, but also instructor supported. They're flexible because students can set their own study schedule and they can enroll 365 days a year. The content on them is well-rounded and in-depth. And the programs, every single one of them, they include job placement training and also job placement assistance. I mentioned this earlier, but they're very affordable. They're priced under the national average. Here's the most important thing. Our programs are designed for absolute beginners. No technology knowledge or experience is required, so you don't have to be a nerd. You can walk in with any background. As long as you can read, write, and do basic math, you'll be fine. We consistently land on every major best coding bootcamp list out there. Our average review rating across all major bootcamp review websites is 4.8 out of 5 stars, and that's based on student and graduate feedback. We work really hard for that. We're proud of it. So now I just want to ask you, like, why would people consider working in tech? We could do a whole discussion and presentation about this, and we have. If you look at our free video list, you'll see something relatively recent. But here's some highlights. The work-life balance in technology is generally really good. There's also a lot of possibilities for remote work. Also, it's a very creative industry, and you can take a lot of personal pride in the work that you do in technology. But finally, it's a really stable industry. The news media will try to convince you it's not. Been involved in it since the mid-'80s. It's stable, it pays well, and if you work really hard, you get stable, regular increases in pay, and they can be significant increases in pay. Now, that said, our method, there was someone early on in the chat was talking about, maybe going to community college, what are the different routes and everything. Our method of doing a boot camp, it does cost, thousands of dollars. It's, 3 to 6 very intensive months. There's a lot that goes into it. So it can cost thousands of dollars. That said, we do have multiple financing options at our boot camp. We have an upfront discount if you pay in full. We have monthly payment options if you have an interesting credit scene. In fact, there's a tuition option for everyone and all financial conditions. But here's the thing I want to point out. There's a lot that can be said about how we structure our boot camps. We don't have the time to cover it in detail, but doing a Tech Academy boot camp is genuinely an investment in yourself. You're giving yourself a solid foundation in technology that'll give you a long-term career, but you're also learning the in-demand skills that the industry needs right now so you can get hired quickly and it's making good money. Time is also a factor in doing a boot camp. It doesn't stretch out over 4 years. It's done in a very tight period of time. Now, some boot camps, handle that time issue by just making you join in a cohort. Everybody starts at the same day and moves through at the same pace. And this is all you're doing 40 hours a week or more. Some boot camps even require you to do your boot camp in person. Our boot camps are done online. We've made it so you can choose your study schedule. And part-time study schedules are allowed, which means you can study concurrently to holding down a job or going to school. Finally, going through a boot camp does require some technical interest or ability, but I want to caution you, it isn't as high as you might think. Part of the reason for that is that if you tried to break into tech or studying the materials, you might have found that some of the technology education materials are too hard to get through. They're difficult, confusing, feel like you're being talked down to. Part of the reason for that, a big reason, is that some technology educators assume too much prior knowledge on the part of the student. I got to tell you, having made a lot of curriculum in my many years in technology, it's real easy to forget what it's like when you're new to the subject. And we've worked really hard to handle that problem. So at our school, you don't have to be a nerd to get through it. And you don't have to have a technical background to enroll. So I have a question. Are you working a dead-end job right now? And by dead end, I don't mean that it's a junky job and you hate the place. I just mean, is there a ceiling to your upper earning potential? If you look at the typical track of someone in your position, your industry, does it hit sort of a wall, $60,000, $70,000, $80,000 or whatever a year, right? Or maybe you're even unemployed. Is it important to you to work from home, to have better work-life balance, to have more time with your loved ones? In other words, is it time for a career change? It's only a question you can answer. I'm asking you to look at it. If it is, the Tech Academy is the solution. We are career change experts. This bridge in our logo is there for a reason. We want to be the route into technology for everyone. We want to make that journey into the world of tech as easy as possible for people, especially people that want to be expert, professional, knowledge workers. At this point, we have over a decade of experience of breaking people into tech. Most of our graduates earn on average $30 an hour in their first job, which is $60,000 a year, which is great. And they're not just working, we have over 1,000 graduates working in tech, and they're not just working at like the big companies, right? Anywhere from small businesses. Everyone needs technology workers. And yeah, we have people working at Nike and Facebook and Disney and Uber and Epic Games and all the big guys, right? And finally, I just want to remind you that we have open enrollment, which means you can start anytime. You don't have to wait. So I encourage you to enroll now. And if you want to, this is the link you use. Regina will drop that into chat. It's our Erik link. And when you click on there, there's going to be a few steps you can do that they just inform you about the Tech Academy's programs and how we work. Because maybe it's for you, maybe it isn't, but here's how to find out. There's videos, articles. There's an optional step even to book a call with our admissions personnel who can answer any questions you have. So if you register on this, great. Complete all those steps after the event, because we're going to get to the free gift in a moment here. I want to show you a couple of things. But fill out the form now. And I've been talking a lot. I'm going to take a second and have a sip of water. By the way, if you click on that link and you're taken to a login screen instead of an application form, if you're taken to a login screen, it just means you already have an account with us somehow. Maybe you enrolled a while ago, right? You can use the information at the bottom of the slide to log into that and pick up where you were in terms of the different steps to learn about the school. Nathan has a great question. And while people are filling this out, I'll answer this question. It says, is JavaScript also used for apps? And it absolutely is. Now, Nathan, this is just me talking right now. 10 years ago, I wouldn't have advised people to specialize in JavaScript because 10, 12 years ago, JavaScript was primarily only really used for website development. And I mean, for making the front end part of a website, the user interface, really dynamic. Not that that's not a valuable skill, but it didn't pay very well compared to other jobs in tech. But in about 2009, this really amazing tool called Node was created. And Node lets you create JavaScript programs that can run outside of the browser. They can run just on a regular computer. It was magical. Now you can write a big, strong, powerful computer program in JavaScript, install it onto a server, a big, powerful computer somewhere, and that program would be able to run. Prior to that, JavaScript programs could only run inside a browser. Like, to be very nerdy and specific, they could only run inside those 2 script words on a web page. That's the only place you can put your computer programs that are written in JavaScript. Now, not the case. So the answer is absolutely, JavaScript is also used for apps. Very powerful. That's a good question, Nathan. It's why we have a whole boot camp just dedicated to being an advanced JavaScript developer. All of our boot camps include JavaScript data, but that one is just become an expert. It's great. All right. Now, since our graduates are very happy with us, for years, referrals have been one of the top enrollment sources for the school. And for years, we've also had a 5% commission payment to anybody who referred someone who signed up. But it's not just for graduates or current students. Anyone can refer someone who's a friend. And when you do so, if they enroll, we will cut you a check for 5% of their commission, of their tuition is the word I'm looking for, right? And we're happy to do it. You've made a real big difference in that person's life, and we'll reward you for it. So in a moment, we're going to give you an email that you can use to send in to request the free gift. If you've got people to refer, put their name and contact information in there, and we'll keep track of it. One last word before the free gift. We have a bunch of publications, 7 of them now. We have 3 Learn Coding Basics in Hours books. We've got a coding book for kids, young adults. We have a technology basics dictionary to explain all these complex, weird terms. We have a project management handbook. We even have You Are Not Stupid, which is amazing. You Are Not Stupid it basically started as a written version of the most important course we have on our boot camps called the Computer Basics course, which removes all mystery from computers and technology. And we added in all modern technology terms and concepts explained and defined, even a history of technology to explain how we arrived at where we are today. You Are Not Stupid is a phenomenal book. All right, our free gift. It's our Introduction to JavaScript book. Technically, it's called Learn Coding Basics in Hours with JavaScript. And I got to tell you, this book rocks. You get a greatly expanded explanation of those 5 fundamental elements of any computer program. And you go way beyond just learning those tiny little basics we did in this short class, and you really dive deep into JavaScript. It's really effective. So if you want a copy of this, and I'm sorry, it's only for people in the US. We can't ship overseas. So if you're in the US and you want an actual physical copy, then grab the email address, books@learncodinganywhere.com. Regina just dropped it in chat. Send us an email with your first and last name and your full mailing address, please. Sometimes people forget to give us their address and we can't send them a book without it. So send that in and we'll send you a book. You can also include any questions you have for me that I didn't get a chance to answer. You can also include referral names and contact information in there. So I'm going to wait a moment for people to fill out, send an email if they'd like to. We love sending these books out. So please, if you want it, grab it. Now, I've mentioned that these videos are going to be available very, very soon. Yeah, Jeremy? Yeah, just send us an email to books@learncodinganywhere.com. We will send you one. They go out really fast. So we're talking about like the fact that we should put these videos up on YouTube. Well, you can find them by going to our link tree. The link tree, if you don't know, is just a service that you can, in one place, have a bunch of links associated with a person or a company. And all of our Tech Academy links are here in one location, right? Regina, if you could drop that link into the chat, there it is. And what you'll find here is links to our free YouTube videos. We have an educational YouTube video playlist where this and lots of other recordings are. You can watch them. There's links to our books, our dictionary, links to our upcoming courses, these free classes we do, right? So there's our upcoming meetups, and all of our social media accounts are on there. So follow us on social media, and please invite your friends to future meetups. If you got anything out of this and you have somebody else you think might benefit, then please share it with them. And finally, if you'd like to win your own copy of You Are Not Stupid, we do give one away every week. And the way that works is, it's 2 things. One, if on your social media, you will share a link to the next class, find the link to the next class and share it on your social media. And 2, if you will tag the school in that post, of course, we're going to know about it. Boom, it comes up on our feed. We'll be notified. We'll keep track of that. And once a week, we give out a free You Are Not Stupid, taken at random from all the people that did that in a given week. So you can win a copy of You Are Not Stupid. And it's, again, it isn't just that Eric, no, sorry, Eric and I'm Eric. It isn't that Jack and I are proud of this book. It's that for years, unasked, people who have it's gotten into their hands have told us, like, this book really changed my life. All right, so thank you for attending. Super appreciate it. Thank you for sticking around. And I hope you got something out of this. Want to see it's the next class, please come to them. And if you filled out that form to learn more about the coding boot camps, do the next steps in there. It'll give you all the data you need, right? And have a great evening. Super appreciate you guys being here, guys and girls.